Welcome to Out of the Lab, a podcast interviewing entrepreneurs who've taken research out of the lab and built it into a company that's serving the world. These entrepreneurs are heroes, and the planet needs more of them. So tune in, learn from their successes and failures, and get inspired. Visit bountiful.work to join our community and realize your power to save the world. Hello and welcome to Out of the Lab. I'm your host, Max Finder. Today's guest is Taymur Ahmad, the CEO and founder of Actnano. Actnano makes self-healing protective nano coatings for consumer and automotive electronics. It's a revolutionary nanotech that Taymur developed very early on in his kitchen. So I really love this interview actually because it's kind of the opposite way of other people that we've interviewed. Taymur spent 20 years in industry, first at Alcoa, a very large aluminum production company, and then at Philips Electronics, which makes tons of different consumer electronics. So he really understood the problem that he was trying to solve up close. And he then left industry with this problem in mind and endeavored to solve it and was testing different coatings all around the world. He ultimately settled on the different parameters that he needed in order to make something work very well. And then he recruited a CTO from MIT and built the company into what it is today. There's a ton of great advice in this, really centering around the fact that there's no replacement for experience. So he recommends, for instance, to young grad students and founders and PhDs to hire that experience, that industry experience, basically to hire someone like him in order to help you go to the customer and help you develop the business side of the technology and understand more details about the problem. So that was really a main learning from this. It was an excellent episode and really got into the details on both coding and printed circuit boards, which is super interesting, and at the same time how to build a technology from the ground up, especially from a place of industry experience. So enjoy. Visit bountiful.work for more and to join our community and listen to the episode. It's a great one. Thanks. Taymur, thanks for joining.
Yeah, thanks for having me.
So I'm curious about the origin of Actnano. I mean, it's almost 10 years, I guess, that you're the CEO of this company now. Can you tell us kind of the origin story and how it began?
Yeah, I think the origin story of our company is interesting because it's very much convoluted with my experience. I think this company is an outcome of the experiences I had in my life. So going back, I'm a little different than your average entrepreneur and founder. I started this company when I was 40 years old. So it's a little later, I think, than what the average founder is. So what that meant is that I had a full career, a full first career before I started the company. And that first career gave me a lot of experiences that are the reason why this company was founded. So I had maybe a 17, 18 year career with big corporations, and it was kind of divided up evenly between two companies, two big companies. There were some others, but two very big companies. One was called Alcoa, used to be called Aluminum Company of America, and now called Alcoa. They make aluminum. And the other one was called Philips Electronics. They make TVs and coffee makers, electric shavers, and all sorts of things. So those are the two big experiences I had. At Alcoa, my job was to, at one point, for 3 years, my job was to convert automobiles from steel to aluminum, right? So it was my main responsibility was to convert steel-built cars into aluminum-built cars. So obviously, working for Alcoa, that was the main thrust, is to increase aluminum intensity in the world. And it was, I had all my arguments ready. and I knew power to weight ratio and fuel economy and safety crumple zones that you create with these cars. And of course, the 0 to 60, is a lot faster. So it's a lighter, better material to make cars out of. And for 3 years, I had to convince car companies to do a material change in the automotive industry, right? So, which is which is a Herculean task for all of your listeners. It's not easy to move the automotive industry into a new material. They're kind of entrenched in their ways and in the way they like to do things, and especially with the welding lines, with the steel welding lines. But I got a lot of experience there on how to do automotive and a material change. So that was one piece of the puzzle that I had in my mind moving forward. So fast forward to Philips Electronics. There, my responsibility was to run 11 factories around the world that made electronic devices of different kinds. And most of the electronic devices are built about the same. They start with a green wafer, and then you have a SMT, something called surface mount technology line. And then you have some kind of wave solder or screen printing process, and then when you have some encasement, you put a little screen on it, a few buttons on it, and it becomes a thing, right? It could be a electric shaver, coffee maker, whatever these things are these days. So the electronics manufacturing process was pretty well defined, still is pretty well defined. And I got to see it up front. And my job was to add efficiencies to these different factories. And there were 2 in Tijuana and 2 in China and Poland and Brazil. So I had these 11 factories that I had to improve. What I noted there was 2 processes that didn't make sense to me. One was this conformal coating process, this process of putting glue type material on a PCBA. So they would take, your Scotch guard type material or glue type material, and they would put it on the PCBA.
PCBA being printed circuit board.
That's exactly right. Yeah, printed circuit board assembly. This is the green wafer that goes inside every electronic device in the world, right? So this is the brains of electronic devices, and the printed circuit board needs to be protected from, let's say, water, because as you know, water and electronics don't mix. So they would put this glue type material on there. Some of them were awful things like isocyanates in it and all sorts of awful things in these. And they would put it on the PCBA, but they wouldn't put it on the entire PCBA. They would leave out areas. They would leave holes in this protection system. And they wouldn't put it on the connector. Of course, if you put it on the connector, you can't make a connection. They wouldn't put it on the processor because processors like to run hot. And if you put something on it, it traps the heat inside. So there's some heat trapping. And then they wouldn't put it on the antennas. Those days that not many things had antennas, but these days everything does. And the antenna, of course, has GSM, Bluetooth, Wi-Fi signals coming in and out of it. This is how the smart devices communicate to the internet. So they wouldn't put anything on the antenna because it would dampen the signal coming out. So I thought this process was, one, slowing the entire factory down. So your throughput was way lower. So you had, the SMT line, the surface mount line would be spitting out hundreds at a minute, 100 PCBs at a minute. And then you would put this glue on there and it would take forever, right? These things are just like 2-3 minute. And then there's a cure oven with heating or UV, but that would take another 10 minutes. So this was slowing the process down, had isocyanates in it, which is not good for the operator standing right next to these operations. So it was bad for the human, bad for the environment, slowing the factory down. And it didn't do, Max, what it was supposed to do. It's supposed to protect the PCBA from liquid. So if I took this PCBA and I submerged it underwater, what would happen? It would fail at the areas you didn't code, right? It would fail at the connector, it would fail at the processor, it would fail at the antenna. So basically we had this umbrella with holes in it and we expect not to get wet, right? So I went on a crusade inside Philips to take this process out of the factories. One, it was ineffective. Two, it was not good for the people working in the factory. Three, it wasn't good for the environment. And in the end, it was slowing the factory down. So our throughput was lower. So it was inefficient, ineffective, bad for humans and bad for the environment. So I went on a crusade to take this process called conformal coating out of the factory. I failed at it because I went back to the Netherlands several times to ask the designers why we do it. And they said, that's how it's been done for 50 years. That's how it's been done. So this is also true, I'll tell you later, but it's also true of the electronics that go into your car. They have the same process, right? Your steering module, your braking system, all the important modules in there, they have the same thing, half protection, leaving big holes in there. So that's I left Philips with that splinter in my mind, that this process doesn't work, right? It's ineffective, it's inefficient, and it's not good for humans and the environment. So the culmination of this company is basically the pivot, the pinnacle of my experiences, which would be doing a material change in automotive and improving the electronics manufacturing in a factory. And so I left Philips with that thought in my mind. And I think in my ideation phase, when I turned 40, I started thinking about, what if there was something we could put on the entire PCBA, an umbrella that does not have holes in it? Then you could take that PCBA and submerge it completely. What if it was fast? What if it was 30-second cycle times? What if it didn't need any curing? No heat cure, no UV cure, right? What if it could go on the processor and doesn't trap the heat? What if it could go on the antenna and doesn't attenuate any signals? What if it go on the connector and you could make a connection right through it and have full conductivity? Now you've got something that you can improve the entire world. And one of the outcome of this would be, you could take your phone and throw it in the sink and it keeps working, right? So that was the ideation phase that I had. Now I don't have a chemistry background, and I've obviously got a lot of factory and manufacturing background. And what I knew is those are the features I'm looking for. Where do I go and how do I get this? There are, if you look at the world of coatings, there's lots and lots of stuff at universities, at all sorts of places. And my search began at that point for that. And then I'll get into it a little bit later on how we discovered the material, how we developed it further, and which teams I engaged to get it out to the market and to be in there. But that's really, so if you think about how's Taymur Ahmad involved in coatings, and why are they coating modules and autonomous vehicles in the marketplace? Why are we coating Teslas and Fords? It's because of my experience. It comes from the Alcoa experience and the Philips experience, and what I learned from those two areas, and what I knew about that's not working in the world, which is basically electronics and water doesn't mix. And we wanted to remove that conflict and make sure that everything worked, even when you submerged it underwater.
Was your age at 40, I'm just curious, did that have anything to do with your desire to kind of leave industry and become an entrepreneur? Try to solve one of these problems?
It's always a factor, right? I think that is an age where you kind of reassess your career, and it's an important age for lots of people. When they turn 40, they want to reassess, and how's it been so far, and what do I do differently in the future? And I'd done the big company work for a while. I'd had important roles and responsibilities. But I always had this idea in my mind that, if I could one day, I would do my own thing. And what does that look like? And, and you can't know what that looks like at 22 because you don't know anything, right? You haven't had the experience. And this circuitous path I took from Alcoa to Philips kind of gave me the experiences to have that light bulb that said, aha, I know what I'm going to do. I'm going to make waterproof electronics. And what if your phone could work underwater? What if your laptop didn't die when you spill coffee on it? What if your car, your autonomous vehicle, kept driving even when your child spills juice in the center console? So those kinds of things. And that last scenario, it's literally a life-saving technology. If you don't do that, you've got a big problem on the autonomous vehicle side.
And so is that something you would recommend to young people, is to do a stint? I mean, it sounds like a 20 or 15-year stint in industry, or to gain some of this industrial experience, because, we've had people on the podcast that are like, okay, we invented this thing, and then we had to start talking to industry to figure out, or to validate our thesis of how it can solve a problem.
Yeah.
That's part of even the foundation for what we're trying to build at Bountiful is this problems first approach. So trying to collect problems from industry and have it be a spark for innovation and connecting the dots that you did. And we'll hear more about how you took the technology. But yeah, I mean, is that something you would recommend to young people, is to really get involved in the industry at first?
Well, I think there is no replacement for experience, where there
Right.
just isn't, right? It doesn't matter how good your PhD is and whether you went to MIT or Caltech. At the end, there is just no replacement for experience. Now, that doesn't mean you have to do it yourself. So this, to your audience, I would say, if you don't have it, doesn't mean you have to get it. Get a partner that has had it, right? No one should be trying to do these big things by themselves. I think there's a lot of founder first mentality going on. Get co-founders, get people that are in the industry, that understand the problems of the industry that you're trying to attack or serve. And I think that's where the value comes from, having some experience and some just raw brain power. So if you look at our CTO, he has a PhD from MIT, and he is that raw power, right? A lot less experience than I do, but I filled the other end of my leadership team with our CTO. So I think you want to do the same. I think your listeners should think about, is there an experienced CEO that we can get that merges well with the raw tech knowledge that your audiences might have. But that experience is how you learn. I think you have to go into the industry first to get that experience, to understand the problems, to see firsthand that, Armando in the Tijuana factory, it doesn't feel very good when he stands next to this factory all day in this process called conformal coating all day, right? That experience stuck with me, and this is why I wanted to do something different. And it just doesn't have, there's just no way to teach that. It takes you standing in the Tijuana factory, watching this operator, cough a little bit with the isocyanates in the conformal coating.
Yeah, and what I love about this too is it's this first principles approach, which you almost approach it like a scientist. Why can't we do all of these different things? Yes, they're technological challenges, but let's try to solve those.
Yeah, and I think that's where the youthful naivete, I call it, helps, right? You don't need too many people who are experienced, because experienced people know why not, right? They know why we can't do that, right? The raw talent, our tech teams, we hire lots from MIT. 80% of our team comes from MIT, and what I like about them, they have the youthful naivete. They don't think that we can't do it. They say how to do it. They try to figure out. They don't listen to the excuses that were being built beforehand. And I think that that is needed. And I think your audiences naturally approach it from that. We will succeed where many before us have failed. I think that mentality has to be there, or don't form a company. That founders have to have that mentality that says, I will do it differently and will succeed where many before me have failed. And I think that's an important lesson to have, and that youthful naivete, the hubris that people have when they're in their 20s and early 30s, that's needed. That's needed. That kind of audaciously optimistic view of solving a problem is needed, but also the experience is needed. So I think a combination, I think joining hands with somebody that has the experience, and then having the same technical raw talent to fix the problem. I think that's the magic combination that succeeds in startups.
So you leave industry with a problem in hand that you want to solve.
Yeah.
What do you do next?
Well, I start thinking about this one problem, the splinter in my mind about conformal coatings. And I know how awful they are. And my biggest driver there is the human working next to the, remember my background is factories. I understood processes and how they were being done. And I just it didn't sit well with me that every single electronics factory in the world was doing this, was putting this awful stuff on PCBs for no reason whatsoever. It doesn't work because you need and so just don't do it, right? We're better off not doing it than doing half of it, because it doesn't work. When you spill your glass of water on it, you can't beg the water to not go to the areas you didn't coat, right? I had one time I had an answer from a very smart engineer in the Netherlands saying, well, we coat 80% of the board. And I used to say, like, it's like a balloon that is 80% enveloped, but you have 20% hole in the balloon. What's that? What's that do anything, right?
It's literally it's literally a useless process.
It is. And for 40 plus years, Max, they did it in the factories. They still do them. Some old mentality factories are still doing it. And it is my crusade to change this. So I leave with this splinter, and I look for materials in the world that could be used for anything, right? All sorts of coatings. I looked for anti-corrosion coatings that people are using for statues, like bronze statues. They're putting these coatings on there. I looked at coatings people are putting on fabric, where they're making it stain proof or waterproof, like Patagonia and these kinds of things. And after looking at
how are you assessing these coatings, and what are you doing? I'm very curious in the minutiae of it.
Oh, it's just empirical evidence, right? You put it on a PCBA, it's got a few LEDs on it, you put 5-volt batteries to it, you submerge it underwater, and you see if it works.
So, but this is something you're doing. This is something you're doing in your home.
I am, yes. It's a kitchen lab at this point. I used to call it the kitchen lab, because I just had my kitchen, and that's where I was doing. So I created these, I had vials from everywhere in the world, from Greece, from Turkey, from, and I would ask people to send me their best, what they think would be a good idea. None of these people are putting it on a PCBA at this point, right? None of these people are putting it on electronics. They're not even thinking about it. They're talking about statues and fabric and glass. Some of them are putting it on for anti-fog, and some of them are doing all sorts of different things. Since I don't have the background to develop it myself, I look for what's the closest thing that might work, right? And this is empirical, just experimentation, right? And I know what I'm looking for, in the sense that I don't want to get too complicated here, but there's something called ball grid arrays, these BGAs, which is a component that goes on a PCBA, which basically has connection points underneath it. So you need to coat those connection points underneath, right? So I'm looking for a viscosity that works for me. I'm looking for a product that goes on the LED and doesn't have a color shift in the LED, and lumens don't change. I'm looking for something that can go on the connector, but displaces when you put the male connector on there. So there's a lot of like criteria that I had in my mind that I need for a PCBA to be successful in a submersion condition. Those, those criteria are obviously very hard to be met, and what didn't meet by any of these coatings that I had in the kitchen lab. So I tried many different things from around the world. I actually went to a few places also at this time. I took the time to actually go visit some of these people in China and some of the people in Turkey, to assess their tech, to see its applications, to see how we could work. So I think I'm a big promoter of go there. Just don't talk to people on the phone. Don't just have, these days everybody's doing video calls, and that's okay. But there's just no replacement for being there. You'll learn a lot more by being there and going there. So I think those were the kitchen lab outcomes, where there was something that would work on one way and then wouldn't work for the signal attenuation, wouldn't work for the thermal neutrality, and that's when you have to dissipate heat at the same rate as if you didn't coat the processor, right? Because nobody wants a heat building up in your processor while you had it. Almost every PCBA now has a processor on it, so it's very hard to overcome that. So like I said, all these problems exist. We've got these BGAs that have connection underneath. You've got the other parts that have leaded, what they call them leaded parts, where these leads come over and attach to the PCBA, and the leads have to be coated fully. They have a tight angle. So if you can imagine this, if you create a very sharp angle on a lead, like a 90-degree angle, the coating will get very thin on the 90 degrees of itself where the corner is.
Right.
And you need to create the coating so that is also very important. So it can't be too thin. The coating can't be too thin. It can't be too thick. It can't be too heavy. If I had an idea that I was going to take this to automotive one day, because of that was my background. I thought this is where we needed, and one of the very simple reason is that if you drop your phone in the sink and it doesn't work, nobody dies, right? You go buy a new phone. In a car, your power steering, your braking system, your autonomous vehicle, your ADAS, it doesn't work, lives are at risk. That's the area that I wanted to really take it to, was to automotive and then to autonomous vehicles.
Okay, and so did the kitchen lab succeed, or eventually you found something, or what was the next? Yeah.
I found a combination of three things. Three of those put together were doing somewhat of a job. It was a nascent technology. Then I realized that I needed people like your audience, right? I needed this, the brain trust from MIT to work on this. So we hired our CTO, and we started building on the nascent idea that I had. And let me give you a little bit of what that nascent idea was. The nascent idea was, if we could keep it in a gel state, in a wet state, in between liquid and solid, right? If we could stabilize it at that point, and it never dries up. It always has that quality of a liquid, but also goes down as a solid. If we could do that, and imagine Jell-O, right? What comes to mind is Jell-O. Then you could put it on the connector, and you could make a connection through, and you could connect and have full conductivity. And when you retrieve the probe, liquids want to normalize, right? So it would kind of heal itself, right? So if you could keep it in that state, right? And that was the one key factor to get connectivity. We had to keep it very thin. Thin was the requirement that we got from the signal attenuation from the antenna side and from the processor, the heat dissipation side, right? Then we also wanted to make sure that it was thin in the sense of viscosity, right? So it would wick underneath the parts, because there's some of the parts, you've seen these PCBs that have 200, 300 parts on it. And some of those parts are very small, but they have connection points underneath the part. And so we have to get there. We have to get there. So you can't use this thick, gluey type stuff that doesn't go underneath there. So we had all these criteria, and I had a combination of 3 or 4 that we thought we could work with, and then we went to MIT. 3 of the MIT professors are on our technical advisory list, and they're very qualified people that once a month meet with our tech teams and guide them into a direction that they want to be going. And so we hired these teams. Well,
can I ask? So you have a theory on perhaps a combination of 3 materials. You know that you need it to be a gel potentially. You have raised money at this point on this?
I have, yes, I have, and it raising money was a little bit easier for me than it is for the average founder. Again, from the experience, right? I knew people at Philips. Many of my old colleagues and friends from Philips invested. Many of my network was bigger than what you would have a young founder have, and they understood the problem. They all knew. They knew who I was. They knew what I've done in my career, and they knew of the problem that I had been talking about. Right? It was when I was at Philips, they heard me talk about this 1,000 times and say, "Why do we do this, guys? Let's take this out of the factory."
Right.
And so they understood the problem. So I raised little money.
Can I ask how much? Yeah, sorry.
Yeah, so it was about $1 million at first, right? The first 2 years we raised about $1.5 million.
And this was a friend and family around, and the objective milestone that you wanted to reach with this was to figure out a way. Yeah, go ahead.
Yeah, to develop the coating that will cover the entire PCB. And in those days, there was a lot of momentum on making a phone work underwater. A cell phone was the thing to make work underwater. So, we knew, we took on the challenge, and we said, okay, we'll make our mark here, and then we'll move to automotive, because automotive takes 4 years to get in anyways, right? Their design cycles are too long, and it takes longer. So we thought, okay, first goal, make a phone work underwater, right? And there might even be a YouTube video out there of me throwing a phone in a beer.
Maybe we can try to find it. That would be cool.
Yeah, yeah, there is. I think this is when Dell invited us to show our tech in Dublin at the Technology Summit, and we took a Guinness tour of the Guinness factory there. And at the end of the tour, everybody wanted me to dunk off my phone in the beer, and I did, and it kept working, and everybody was very happy. And
that's a thick beer.
Yes, that is. And so it was our first foray was there. I knew what needed to happen. I raised money on the idea that we can do this. I think people believed in me and knew that I know a little bit something about something on the electronics manufacturing side, on the automotive side, and I have a few ideas on how we could make it work. The gel state idea was really the winner of all of this. It really worked when we created a gel state thin coating. So at this point, we raised a bit of money. We went and hired the best talent out of MIT, and we charged them with this idea that we're looking for this and develop in this direction, which it has to be gel state and a very thin coating.
And I have two questions on this actually. Did you think at all about licensing a technology from a university anywhere?
I did think about it. I actually went to University of Athens in Greece. They had something. I would have, only it didn't work, Max. I mean, when brought back to my kitchen lab, it had to work. Otherwise, there was no point, right?
Right. So
Otherwise, I was
you
just
were
licensing.
you were assessing these technologies the same way you were assessing, the way you were purchasing from larger manufacturers.
Yes, yes. And look, one of the things, Max, the easy part I knew what I was looking for, and it was a binary answer, right?
Right.
You submerge, it's that easy. You submerge this PCBA underwater at a 5 volt or 13 volt, depending on its automotive or consumer. And it either works or it doesn't work. Either the LEDs come on or they don't. That's it. That's how simple the test is. And I think that was, seems very simple, but was near impossible to do without some development.
And how did you assess the hiring of that development? You thought to yourself, I need a PhD from MIT with some type of, polymeric coating
Coding,
experience.
yes, some kind of coding experience. So when I interviewed lots of people, but let me give you an idea why our CTO, he had excellent experience.
Yeah, I think it's useful to our listeners who potentially want to make a transition like this or something.
Yeah. So he had excellent experience. He had gone to Chile to do some fog harvesting work. Now, can you imagine what that's like? You would put up these structures and fog comes in Chile every morning. They don't have good running water or some clean water, access to clean water, but fog comes in. If you could have the droplets or the humidity in the fog attach itself to this structure and then kind of beat down to a bucket, then you've got clean water. Every morning you have this fog go through and it just kind of, so fog harvesting was, but he had studied in detail the surface qualities of, let's say, hydrophobicity and humidity, right? What water does to a surface and how to attract it or repel it. I think that was very important work. Actually, when I interviewed him, he'd already taken a job at another company that did glass, like they were doing hydrophobic coatings for inside a ketchup bottle. So your ketchup would just come out easy instead of banging it on the back of the ketchup bottle.
Okay.
So he was actually working for that company because he'd defended maybe 6 months before then, and he was working for that company. And I knew that his talents were being underutilized there, and so he had that experience of how to make glass hydrophobic, and then he did the fog harvesting. He had written a few papers on textile. I think one paper on textile and one on glass, where how to make those surfaces change behavior. And in the end, what we're looking for is this PCBA surface to change its behavior, right? To not make contact with the water that's being thrown on it, and to displace itself when there's a connector coming through, right? So it needs to insulate and conduct at the same time. So conduct when you make metal to metal contact and the coating is displaced, and insulate when there is no metal to metal contact and you just throw water on it. So yeah, so I think I call him the Wunderkinder because his last name is Kleingartner. And so he's got a German last name. So but I think that's how some of our selection process went. But remember, I'm doing it in the opposite direction. I was the business end, the experienced end, and I hired the technical end. I think I think if your audiences have ideas, they need the business end, they need the other side to understand the experience side, to understand the problem a little bit better, instead of just having the technical knowledge on how to solve it.
And it sounds like you continued to further embed yourself in MIT with some in your
Yeah, well, I
substantive.
mean, with him, he brought, you know, his network, which was of course lots from MIT, and you know, the chemical engineering program at MIT is very successful, and we continued to hire from that program. Then we also went into material science and also hired a few chemists. So we've got a few chemistry PhDs, and then a few material scientists, material science PhDs. But chemical engineering being our main focus on how do we create a coating that does what we're looking for it to do.
And did you start to chase non-dilutive funding at some point? Anything like NSF
Yeah,
grants? Or,
so
yeah.
you know, I think this is going to be a big number. It's going to scare your audience, but we got to about $8 million on our own in raise. Just, you know, that 1.5 became 8 pretty fast, and
Because you
that
reached the
was
milestone that you had.
because we reached the milestone. We even got our first customers. So we got, I think, in 2014, we had 2 very big consumer electronics companies. So, you know, that idea of phone working underwater, that happened. And, you know, it started flooding some revenue into our company. And so that worked. And of course, everybody that was an early investor doubled down. And then we got some more people involved, and more senior people from different parts of the world also got involved. You know, I had a network that was global, so Korea and Europe, and so that really helped. That really helped in that building. And then eventually we did a Series A round, like from institutionals, as you know, like Material Impact, and Emerald, or the financial VCs, and then of course big companies like Henkel and PTT Chemical out of Thailand also invested into our company.
Very cool. And so, if you had to think back, and you know, I'd like to know what advice you would give yourself, what you would do differently potentially from either when you founded or even when you left university. I mean, you have an engineering degree and an MBA, right? I mean, when you know, take either when you left university or when you founded the company, how would you, what advice would you give yourself, or what would you do differently?
Yeah, so wow, I mean, there's lots of stumbling points, right? No one has, most people when they do a startup is their first go. They don't have any experience on how to do it, and it doesn't matter how much experience I had on the corporate side. You know, this is a whole different animal. Doing your own business is a whole different animal. So so approach it with humility, that doesn't matter how much experience you have or how much technology you have. The startup world is a very different part of this business ecosystem, and there, you know, be resilient. I think the advice, that's not advice. I'm kind of naturally very resilient, so that's not the advice I would give myself, but I would make sure that your audiences have that in there. That's the number one advice. This is not for the faint-hearted, and you have to be resilient. You're going to get knocked down 100 times. You got to get up off the mat and start fighting again. And so that's the general advice. What I would tell myself is, you know, go earlier to the customers as soon as you can, right? I worked in the kitchen lab for too long. and because I thought I knew the customer, which was me from my Philips days, right? I knew what the factory wanted, I knew what the designers wanted, I knew how to, and so that was great. But when we got to the customers, we learned even more problems, right? And they were nothing to do with the technology. It was, we have a 3-year contract with this other company that we buy conformal coating from. Or it was, our lines are set up this way. We already bought the oven that's sitting there that, it's a thermal cure. And what are we going to do with this oven? So I think lots of things will happen. I think go to the customer earlier, stop working in the kitchen lab and start talking to customers, and be humble about it and say, I don't have an answer. I want to do an exploratory meeting with you. And if you have some time, just tell me about your problems, and we'll see how we do there. So I think going to customers a little bit early. I had a little bit of a hubris on that, where I thought I knew what the customer wanted, especially on the automotive side, right? I knew electronics and I knew automotive and I knew what they needed. But the earlier, had I gone earlier, so we started going to automotive in 2014 and we were in cars in 2018, right? Had I gone earlier to the automotive guys, then we would be on cars earlier. The earlier you talk to them, the earlier you're gonna be in production.
Who is it at the customer that you think that is the correct person to try to speak with? Like if you're cold reaching out or asking for intros, I mean, what you're targeting the CTO's organization, the R&D departments? Is there any
Well,
advice
I
there?
knew a little too much, and I think that was helpful and a hindrance. So I knew exactly how these decisions are made and who makes them, right, on an electronic device or laptop, right? Who made all those decisions, where the keys go, and everything else. So to me, that I knew there's a triad of people, right? There's a product design team, right, that's designing where everything goes, what hardware we're going to put on it, all this other. So there's a designing, that they're looking for features and functionality and these kinds. So there's always a product design team. Then there's the purchasing team, right, that they're just looking for the cheapest thing and how to buy and big volume, and if you're big enough to buy from, or these kinds of things. And then there's the factory, the plant manager, the people that actually make the stuff, and they have a lot of say in how things get bought, what gets bought, what comes into the factory and gets put on. So I knew that there was the triad of decision makers there: the factory, the purchasing, and the design teams that I had to go back to. I would say that's not always going to be the case for your audiences. So I think for them, they always have to say, who has the problem? Whose problem is it? And start there. And generally it's the product design team. Generally it's the product design, the product manager of whatever you're trying to improve, whatever you're trying to help. You have to go to them. If it's a consumer product, then it's then you have to, you have to be a little more careful and try to figure out like what's really important and that's the hardest part to figure out. If you have a consumer product, then consumers are the customers, and you have to try to figure out what they want. But if you're selling B2B, a product design team is where you start.
Yeah, it's a theme across the interviews that we've done so far. Is everyone, a lot of people have echoed that same sentiment: get to the customers and industry as early as possible and start talking to them. And it's counterintuitive because you feel like they're going to steal your idea or steal your technology, but the learning that you can do is mountains above, what you would do from the kitchen lab, I guess, right?
Yeah, and they won't know, Max, what you don't tell them, right?
Right.
Have the belief in yourself that you know when to hold back and when to say what, right? And I think that comes with poise and experience also, but also this is why you need the experienced person to go in there with you, right?
Right.
So what I would do if I was a young PhD that had an idea, I would partner with an experienced person from a customer, right? So I would hire if we had done it in reverse. If Justin was the one with the idea from MIT and wanted to do this, he would hire the guy from Philips, right? And say, okay, you know how these things work. Now let's go together to Philips, to Dell, to LG, to whoever it is, and make our case, or at least just learn it first, to what's bothering them, and then we can create a better sales process. So I think in the end, this partnering, I think that's how you go to the customer early. You get somebody from the customer to come work with you.
Well, that's excellent advice. I think this is a good place to stop. And Taymur, where can people find you if they want to reach out or connect, if you're open to that?
Yeah, so of course on LinkedIn, as everybody else is. Our company is Actnano on LinkedIn, or you can go to actnano.com, and I think that'd be excellent if you could follow our company and see our progress.
Awesome. It's very exciting. We're looking forward to seeing what you come up with in the next 10 years. So Taymur Ahmad, Actnano, thank you very much. Visit bountiful.work for more, and stay tuned, folks.
Thank you for having me.
Thanks for listening, but now we need your help. We're building a community of scientists, students, entrepreneurs, industry leaders, and investors to commercialize meaningful technology and research. Join us at bountiful.work today to find opportunities and realize your power to save the world.